Hello, good morning. All right, here we are for our second day of biology. And today the goal really is to start to dive into what science is and how we're going to be using it. So I'm just going to go straight into it. Hopefully, class is good, but if we're still experiencing technology issues, come watch a YouTube video. Allow me to help you. So, first, let me present out my other screen. Boop. All right. So here you should be seeing a bunch of scientists on screen. And what I want to point out is that this is what a lot of people think science has to look like, and it doesn't. The best scientists on the planet are actually things like babies because they don't know much about anything. They're struggling to understand the entire world. They literally need to learn what is up and what is down. And that's done through trial and error, experimentation. Now, science for our purposes, and this is our first page of notes, so hopefully you remember the stuff in white is flavor text. You can write it down if you want to, but you don't have to. The stuff in yellow, that's the important bit that I want to make sure you get because that's what you're going to be asked and questioned on. So what is science? If we take it in its simplest form, science is just a series of steps to gather knowledge about how the world works. That's it. It doesn't need to be this incredibly fancy thing. Much of our science has advanced unbelievably. And if we take a look at the kinds of things that it has now given us, you can see a huge number of advancements that have all happened in like the last 150 to 200 years. Humanity has been on this planet for more than 100,000 years. But all of these things that we think of as being just standard part of life weren't. These are all things that we got from people following and doing good science in order to advance our lives. Stuff like cars or electricity that a lot of people understand. Yeah, they probably haven't been here forever, but I don't think people really understand how new they are. For this class, we will be looking mostly at biology, though, the study of living things. We'll be talking about the breakdown of that word in the future. And in order to start to get into this, we have to get our basics done first. So the first basic thing that everybody needs to understand is our unit of measurement. And we are going to be using the metric system because America is actually still fairly young. This is not an old country. We're still one of, I think, the first or the most recent 30 countries that have existed on this planet. So people may act like we've been here forever, but we have not. So we're like a new kid. We moved into the district. All these other kids already knew each other. They've been around for a while. And so we have to use the same language they do if we want to share our data with them and they want to share their data with us, which is the point of science. So let's start. The metric system is a unit of measurement. So for mass, we're going to use grams. For length, we're going to use meters. For volume, we are going to use liters. Now, the nice thing about the metric system is that everything works in a base 10. And what that means is you're just shifting zeros. That's all you're really doing in order to change the numbers. If I asked you how many inches are in a quarter mile, you would first need to find out how many feet are in a quarter mile. And then you're going to need to multiply that by 12 in order to find out how many inches are there. There's math. We don't want to do math unless we have to. So we use the metric system because it is so easy. Let me show you. Kill presentation. All right. So here is our basic metric conversion scale. Here is our normal with grams, meters, and liters. If we go smaller, it's further down. If we go bigger, it's higher up. Now, if we take 1 gram and we move up the scale towards kilograms, then you're going to notice what we did is we just moved the decimal. We moved effectively the zeros place. As we're climbing that hill, this number is going to get smaller and smaller and smaller. If we're going for centigrams, we're going to go down the scale. So this number is going to get bigger and bigger and bigger. All we really did was take the decimal, and if you're going to go down, you're going to move it this way. And if you're going to go up, you're going to move it this way. So this number 1, to go down 1 step, we just moved the decimal over 1 place. Now it's 10. To go to centigram, we moved it over 2 places. 1, 2. Now it's 100. If we're going up, we're just going to move it the other way so the number gets smaller. So if we start with 17 meters, our measurement for length, and we want to go to centimeters, well, we're going to go 1, 2 steps. So we're going to move the decimal over 1, 2 places. (1,700 centimeters). If we want to find out 17 meters is how many kilometers, well, we're going to take that same decimal, but now we're going to move it over 1, 2, 3 places, because it has to go 1, 2, 3 jumps. (17 meters is 0.017 kilometers. That's the metric system. And it doesn't matter whether it's grams, meters, or liters. It always works the exact same way. Why is this good? No math. You just got to shift it. Up, down, left or right, however you want to envision it, works. But the metric system is always super, super easy. All right, let's go back to the slideshow. All right, so it's also worth noting that because we're the new kid on the block, let's take a look at the world then. Let's see what amount of the world uses the metric system and what areas in the world use the US imperial system. Well, if you take a look, everywhere in gray uses the metric system. Everywhere in red uses the imperial system. So it's America and Alaska. And then we've got one little country in Africa and one country in Southeast Asia. And that's it. So we really want a common way to speak to the other countries. We'll also be using Celsius as our temperature. Now, if I ask you this simple question, what is freezing to boiling in Fahrenheit? Most people know that freezing is 30, 32 degrees. What's boiling? It ain't 100. If it were 100 on a hot summer day, we would start to boil. The boiling point for Fahrenheit is 212. All right, that range is really messy. It doesn't make a lot of sense. You're talking about 180 different numbers in there between freezing to boiling. Celsius is simple. Celsius is based on water. So water freezes at 0 and boils at 100. So we'll be using that if we can get into the lab to actually measure temperatures. It's also weird when you get one of these thermometers because it's hard to tell exactly what the Celsius side is over on the Fahrenheit side. I have friends from a lot of my online games who live in Australia, and they would be complaining that, oh my God, we're dying. It's 38 degrees here. And I'm thinking 38 degrees is freezing cold. What are you talking about? Look on this scale for where 38 Celsius is. And you'll see it's about 100 degrees Fahrenheit. So there's a big difference there, and it's good to know which scale you're using when you're trying to talk about temperature. Now, the last thing that we needed to work on was we needed a language. We needed something that we could use, that we could make use of. Now, this animal at the bottom of the screen is what? Now, depending on where you are, just in this country, it could be a lot of things. We call them mountain lions in New York, but in Texas, they're cougars. In Florida, they're panthers. In Montana, they're called pumas. But it's all the same animal. So you can imagine wasting months, maybe years of your life studying this animal to try to really figure out how it works, only to find out that somebody else has already done the same thing. They found out the same things that you did. You did not actually discover anything new. They just published their work under the name Puma while you were using mountain lion. So we needed some way that everybody on this planet could talk to each other and make sure that we weren't doubling up and wasting our time. And so we use Latin. Now, Latin is an easy language to use because it's dead. That means that nobody speaks it anymore, and so it doesn't change. In English, words changed their meaning. Good examples of that. I have a few of the old ones there, but like I remember even just a couple of years ago, people would use the term beast or boss to describe something that happened. That's already gone. English has changed. The way we use the words change. If somebody does something and you say that's cool, you're not referring to its temperature. You're referring to that you like it. All right, that's language evolution. We don't want that in science because we want the name to be the name. So Palinurus vulgaris, the spiny lobster, we want to make sure that for everybody in the world, forever, all it means is a spiny lobster, which incidentally looks like this. And so with the metric system, with our Celsius temperature, and with our Latin language, we're able to better communicate with other people and better share the data that we get. If I see you in class, I'll tell quite a story about that lobster. So we see this all over the place. The domestic cat, Felis catus. You can look through the different animals that you see here branched off of each other, and each of these are their Latin names. So the wolf is Canis lupus. We, of course, are Homo sapien. Right up there. And of course, then there's Panthera leo, the lion. Now, I don't know if this is going to play for you guys. I'm going to fast forward it a bit. This is, let me mute them. This is a tour group that's out riding elephants. And then all of a sudden this happens. And that tiger just jumps straight up and tags the guy. So when you see a lion looking at someone's car like that, it is entirely possible that that lion can get that person. They can do those kinds of jumps. So ladies and gentlemen, we've covered our basics. We're going to be working a little bit more with our Latin and taking a look at prefixes and suffixes. So hopefully you guys can get an idea for how they come together. But for right now, this is going to be pretty good. I hope to see everybody in class and have a good day. And stop recording.